This video is included in the series of short examples of inequalities. Welcome to Mathematics of Engineering. There are 5 types of inequalities, the first one of which is linear. By the name, the degree of inequation is 1, which means the exponent of the variable is 1. The second type is quadratic, which has a form where the variable x is squared. The third type of inequality is rational, which has the form with a denominator, analogous to a rational function. The fourth type of inequality is compound, which can come in 2 different formats. The first format contains 2 inequalities connected by and or or. The second configuration of compound inequality is a series of inequalities connected by 2 operators. The last type of inequality is absolute value, which includes a modulus. Each of these types of inequalities has a distinct operation to get solved. The third example has the inequation of x squared plus 2x over x less 3 as greater than 7. Having a denominator entails that we are to approach the problem using rational inequality solution. So starting from the denominator, which is x minus 3, we are to take x as not equal to 3, so as not to zero out the denominator. X as 3 is the first marker. From the numerator, x squared plus 2x as greater than 7, zero out one side. In this case, subtract 7 from both sides, making x squared plus 2x minus 7 as greater than 0. We have just created a quadratic equation, although it seems like we cannot use basic factoring. So the other option is to use the quadratic formula. Plug in the coefficients of 1, 2, and negative 7. X is then negative 2 plus or minus the root of 32 all over 2, or that gives x1 of negative 1 plus 2 root of 2, or 1.828. The second value of x is the other sign, making negative 1 minus 2 root of 2, and this is negative 3.828. These are the other markers for the inequation. Placing them into the number line, negative 3.828 carries a hollow dot along with the positive 1.828 and also with the positive 3. Having 4 ranges, validate which is true. The first range is from negative infinity to negative 3.828. A value within this range is negative 4. Plug this into the inequation to have the square of negative 4 plus twice of negative 4 all over negative 4 minus 3. Simplify and have negative 8/7, and this isn't greater than 7. The next range, from negative 3.828 to positive 1.828, will use an assumed value of 0. Place 0 as x into the function, making it 0 squared plus twice of 0 over 0 minus 3, giving 0, and definitely this is not greater than 7. The third range includes values from 1.828 to 3, so let's use 2. Place 2 into the function and have the square of 2 plus twice of 2 upon 2 less 3, giving negative 8, which is still not greater than 7. The last range is between 3 all the way to positive infinity. Assume x of 5 and plug this into the inequation to have 5 squared plus twice of 5 all over 5 minus 3. This is then half of 35, which is greater than 7. Thus, we have the solution to the inequality, which is from 3 exclusive to positive infinity.